Cross-site scripting. I'm actually really glad that's over, so let's move on to command injection, which is the next room in the junior penetration tester path. And as I said in previous videos, I'm going to add my own twist to these from my experience as a penetration tester, because there probably have been others before me that have done walkthroughs for the TryHackMe rooms, learning paths, and so on and so forth, whatever they call them on this platform. So command injection. Let's start the attack box, and if we have a machine, let's also start a machine, but maybe we would not get this far in this video. So I'm actually going to keep it in the ballpark of 20 minutes. Make sure we're recording here. 20 to 25 minutes. If we spill over, we're actually going to divide this in two videos. So, command injection. In this room, we're going to be covering the web vulnerability that is command injection. So, not only when you encounter an input or anything, when you encounter a field, a parameter, or something that you can interact with, two things that you have to keep in mind is validation for the field and injection. And if you break down each of those, you can get into the types of vulnerabilities that are discussed all over the place. But if you have this in mind, so injection and validation, you can maybe develop your own approach and maybe find, if you keep an open mind, you may be able to find something new as a penetration tester. So I'm not talking about bug bounties. I'm not, again, highlighting, I'm not talking about bug bounties. This is for the penetration tester. So for someone who works on a project, who's been assigned on a project as a penetration tester, or who does penetration testing in any way, shape, or form. Once we understand what this vulnerability is, we will then showcase its impact and the risk it imposes on an application. Then you're going to be able to put this knowledge into practice, namely how to discover it, how to test and exploit it using payloads designed for different operating systems. Not necessarily, so not everything runs on top of an operating system. So if you try to keep an open mind and be as abstract as possible, you are far better off than if you try to label and try to find specific cases for specific issues. How to prevent this vulnerability? Maybe we're not necessarily that interested in the blue team stuff, because as a penetration tester your color is red predominantly, but of course you have to provide mitigation steps and fixes to whatever you're testing in your report. Lastly, you'll get to apply the theory into practice, which is probably the most important thing. Now, to begin with, let's first understand what it is. It is the abuse of an application's behavior to execute commands on the operating system, using the same privileges that the application on a device is running with. So, first off, when you're running command injection, or when you've encountered command injection, it usually runs with the same privileges as the application. So if you find a command injection on a web application, oftentimes in scenarios, if you're able to execute commands on the operating system, for example, if you're on a Linux system, then you might try to see who you are by running the command who am I, and you'll often see that you're data. That's for usually for web servers, for Apache web servers. For example, achieving command injection on a web server running as a user named Joe will execute command under the Joe users and therefore obtain any permission what that Joe has. Alrighty. A command injection is also known as remote code execution. So nomenclature, we're maybe not really that interested into this. The web server will process this code and execute it under the privileges and access controls of the user who's running the application. Command injection is also known as RCE because of the ability to remotely execute code within an application. Command injection, remote code execution. These vulnerabilities are often the most lucrative to an attacker because it means that the attacker can directly interact with the vulnerable system. For example, an attacker may read systems or user files, data, and things of that nature. For example, being able to abuse an application to perform the command who am I to list what the user account the application is running will be an example of a command injection, or ID, on the same line with who am I. Command injection was one of the top 10 vulnerabilities reported by Contrast Security's AppSec Intelligence report. So it's been on many top 10 vulnerability lists all over again because it's still encountered, because there are often times when an application needs to run commands on the operating system most of the times, and the best approaches of developers who are running or who are building applications from scratch, it often is the case that some of these ways by which the application runs command on the system are not properly sanitized and validated. Moreover, the OWASP framework constantly proposes vulnerabilities of this nature as one of the top 10 vulnerabilities of a web application, and be my guest to look at the OWASP top 10, which is over here. You need to know this as a penetration tester, and moreover, not only the top 10 but also the OWASP ASVS checklist, which is a checklist for application security verification standards. Really important when you're doing a penetration test and you're running out of ideas. So if you're like you're testing like free flowing in your approach, it's better to be methodical and actually have a checklist to be able to cover as many cases as possible, to cover as many areas of exploitability as possible. And I have a few on hand. So it's the web application penetration testing checklist. I run over this, which I've shared on my Twitter account. So go on Twitter and look on my recent tweets at my Twitter handle, which is in the description of this video. And you'll actually, if you're a penetration tester, this is going to be really useful. 3 other tools. It's the cheat sheet by Hex Niva, if I'm saying that correctly, the one by 6toDes, and the one by Hacktricks, which is over here. Doesn't want to load for some reason. Let's actually go back. Where were we? / I believe that was this one over here. So I may be going over them step by step in future videos if some of you are interested in that. Answer the question, no answer needed. Alright. This vulnerability exists because applications often use functions in programming languages such as PHP, Python, and Node.js to pass data to and to make system calls on the machine, as I said. In this code snippet, the application takes data that a user enters in an input field named title. Let's actually see. To search a directory for a song title, let's break this down into a few steps. So, step number 1, the application loads a list of songs in the var html songs. The application stores MP3 files in a directory contained on the operating system. That's what they say. Now, the title, so in this situation they're creating a variable called title, and it actually gets whatever is in the field title in the web application. The user inputs the song title they wish to search for. The application stores this into the title variable. Number 3, in this situation you grep for title, so you're actually doing a search for the title in this songtitle.txt. So where is the issue so far? The data within this title variable is passed to the command grep to search a text file for the entry of whatever the user wishes to search for. Number 4, it actually executes the command. So if there is no input in the search, so if the search is empty, the requested song does not exist, and it actually lists the title of the song. Else, return the requested song title does not does exist. Alright, so in this case there is no check, or there is no validation. So in this situation it will actually grep for whatever the title. But where would the command injection issue be here? So for example, if in the title field you're actually inputting another command, so if you're terminating the grep command, you can terminate the grep command, for example, with semicolon. You can do an and or just an and. These are the first things that you should check when it comes to command injection. Now, the output of this search will determine whether the application informs the user that a song exists or not. Now, this sort of information would typically be stored in a database. However, this is just an example. Of course, an attacker could abuse this application by injecting their own commands for the application to execute. Rather than using grep to search for an entry, they could ask the application to read data from a more sensitive file. So in this situation, they didn't go as far as I envisioned, but they also said instead of grepping for the title, you could just input grep etc password, and then you would finish this command, and whatever goes afterwards in this situation would lead to an error in this specific situation, because it's only going to, so after you finished the title you do a semicolon, so grep etc password semicolon, and it's actually going to lead into an error afterwards, because it's going to process etc password, and the next command is going to be var html. So it's not actually gonna do anything. But if you would like to be more thorough with this, you could just terminate this into something that will start a comment in PHP, and I'm not actually really sure what's the syntax for starting comments in PHP, but regardless, that's how they thought of it. Abusing applications in this way can be possible no matter the programming language the application uses. As long as the application processes and executes it, it can result in command injection. For example, this code snippet below is an application written in Python. So we're importing subprocess, which is actually used in Python to process system commands, and then they're using the Flask framework to write web applications in Flask. Let me take a sip of coffee. The first one for the day, which is the tastiest. So it instantiates an app. It's how you do it in Flask. I don't know Flask. I haven't been writing applications in Flask, but I am familiar with it from a source code review perspective. Then they define a command, which is execute command, which takes a parameter shell. And in this situation it returns, so this is how you run commands in Python. One of the ways in which you can run commands in Python using subprocess. Another one is the OS library. So subprocess popen process open shell, this is the first parameter. Then the second one, shell equals true. This is not necessarily redundant. And the standard out is subprocess.pipe, then so subprocess process open standard out read. This is probably actually going to process it to the standard output. Alright, and then def command server. So in this situation, app route is /shell. Not actually the best at this. And on this actual route, they define another command, server. And this command is actually, the purpose of this command is to return the output of the execute command. Alright, very basic. The Flask package is used to set up the web server. Number one, a function that uses the subprocess package to execute a command on the device. Of course, we use a route in the web server that will execute whatever is provided. So in this case, this is the route and whatever is provided in that parameter. So route, if you provide a who am I, as it says here, you're gonna get the output of the command who am I. What variable stores the user input in the PHP code snippet in this task? Is it the title? What HTTP method is used to retrieve data submitted by a user in the PHP code snippet? What HTTP method? Is it the get method? Yes, it's the get method. Get method with my Romanian accent. If I wanted to execute the ID command in the Python code snippet, what would I do? /ID. Alrighty, number 2 is done. 3, 4, 5, 6. And the time is 16 minutes. So let's do another one. You can often determine whether or not command injection may occur by the behavior of an application, as you will come to see in the practical session. Applications that use user input to populate system commands with data can often be combined in unintended behavior. So as I've told you previously, you have the shell operators, semicolon and and will combine 2 or more system commands. If you're familiar with Bash, then you're probably very well aware of this. If you aren't unfamiliar with this concept, it's worth checking out the Linux Fundamentals module to learn more about this. Maybe we'll get into it in future videos, and I take the opportunity to tell you to share this video all over the place, because this is actually going to motivate me to keep on doing these videos, sharing my personal perspective and my approach when it comes to penetration testing, using these examples on TryHackMe and other platforms in the future. So share this video everywhere if you want me to keep on going on making these videos, because otherwise, if these videos don't get any views, that I'm not motivated to actually do them, because I'm doing this for free, I'm doing this in my free time, and I'd rather actually learn something if this is not worth my time. I have defined, so command injection can be detected in mostly one of 2 ways: blind command injection, verbose command injection. I have defined these 2 methods in the table below. So blind, this type of injection is where there is no direct output from the application when testing payloads. You will have to investigate the behavior. So when you're doing blind, you're actually trying to see, broadly speaking, 2 scenarios. How would the application behave in a successful command injection or in an unsuccessful command injection? And that's actually the case for blind SQL injection, when the determinator or the determining factor is the time it takes for the command to actually process whatever input you're giving it. And verbose is actually the happy case, where this type of injection is where there is direct feedback from the application once you have tested a payload. So if you run the who am I, you're actually gonna see wherever the output is processing within the application the result of this command. Now, detecting blind command injection, let's see if they say what I just said. However, there is no output visible, so it is not immediately obvious. For example, a command is executed, but the application outputs no message. For this type of command injection, we will need to use payloads that will cause some time delay. For example, the ping and sleep in some frameworks works. Using ping as an example, the application will hang for X seconds in relation to how many pings you have specified. Another method is by forcing some output. This can be done by using redirection operators. If you are not familiar with this, again, the Linux Fundamentals module. We can tell the web application to execute commands such as who am I and redirect it to a file. That's really clever. We can then use a command such as cat to read this newly created file contents. Or if we have access to the file within, if we're talking about a web application, if we have access to the certain file or the certain directory, we can just manage our way through to that specific file. Testing command injection this way is often complicated and requires quite a bit of experimentation. So if you have a lot of time when you're doing a penetration test, by all means go ahead and maybe you learn something new. Or in this case, I've said I won't be talking about bug bounties because I'm not really interested in that. There might be situations where some big bounties are up for grabs, and you might want to spend more time if you have the feeling that a command injection scenario might be at stake. The curl command is a great way to test for command injection. This is because you're able to use curl to deliver data to and from an application in your payload. Take this code snippet below as an example. A simple curl payload to an application is possible for command injection. So curl to the vulnerable app process.php, search the Beatles, and then after that, this is probably %3b. I'm not actually sure what %3b is. It's maybe and or semicolon, I don't know. And then you have a space. I believe this is a space. And then who am I? Detecting command injections this way is arguably the easiest method of the two. So verbose command injection is when the application gives you feedback. For example, the output of a command such as ping or who am I is directly displayed on the web application. You have a list of useful payloads. Who am I, ls, ping, sleep, and nc, netcat. So you can use the command injection to spawn yourself a netcat to actually create a backdoor into the application so that you can connect using a terminal and maybe then escalate your privileges to not necessarily a higher privileged user, but to a more stable shell, for example. Now in Windows, who am I, dir instead of ls, ping, and timeout. What payload would I use if I wanted to determine what user the application is running as? It's the who am I. What popular network tool I use to test for blind command injection on a Linux machine? So ping. What payload would I use to test a Windows machine for blind command injection? Is it timeout? Alright, remediating command injection. Do we have time for that? Let's actually do that, and then in the next video we're gonna do 5 and 6. Command injection can be prevented in a variety of ways, everything from minimal use of potentially dangerous functions or libraries in a programming language. Of course, I have detailed these a bit further below. So these are for PHP. Vulnerable functions in PHP are exact pass-through and system. So if you do not have to use them, do not use them. Take the snippet below as an example. Here the application will only accept and process numbers that are input in the form. This means that any command such as who am I will not be processed, which is really good. The application will only accept a specific pattern of characters. In this case, they're using a regex. The application will only proceed to execute this data which is all numerical. Alright, input sanitization. Sanitizing any input from a user that an application uses is a great way to prevent injection. An input field that only accepts numerical data or removes any special characters such as the piping, so the directing character, the end, and the /. The filter input PHP function is used to check whether or not any data submitted via an input is a number or not. If it is not a number, it must be invalid input. So you're using a filter, which is a good way to mitigate these issues. Now, bypassing filters. Applications will employ numerous techniques in filtering and sanitizing data that is taken from a user's input. These filters will restrict you to specific payloads. However, we can abuse the logic behind an application to bypass these filters. An application may strip out quotation marks. We can use instead the hexadecimal value of this to achieve the same result, and they wouldn't think we're gonna use that. When executed, although the data given will be in a different format, it would actually mean the same thing. So it can still be interpreted and will have the same result. What is the term for the process of cleaning user input that is provided to an application? Is it filtering? It's not. Sanitization, sanitizing, sanitizing. Sanitization. Is it that? Sanitization. Alrighty. So next, task number 5, the practical, and task number 6, the conclusions.